In this presentation, we'll introduce the tilde in rule, and then we'll complete the first set of 10 practice problems. As was the case with the arrow in rule, tilde in rule uses a PA. So what we want to do is, what we'll have is a conclusion with a tilde in it. So we have something over here, and this is going to be our conclusion. And it's going to have a tilde somewhere next to it. And what we're going to want to do is we're going to want to assume the opposite of the conclusion, or sorry, you could also think of it as the conclusion without the tilde. So we're going to write the conclusion as a PA. So, and then we're going to build what's called a contradiction. So we're going to look for something that has the same thing on both sides, just with a tilde next to one of those sides. And then if we build a contradiction and it depends upon our PA, that is that we posit in one of the earlier lines, which is the opposite of the conclusion, then we can do the tilde, the conclusion. This one's a little bit more complicated to sort of show in the straight rules that we've been doing. So it's probably just going to be much easier to start going through the first 10 practice problems, and then you'll get a feel for what's going on. But the idea is almost always the same. There is something in which we are building towards that we're trying to prove, and we're going to take the opposite of it, meaning the thing, the conclusion or the statement that we're looking to get without the tilde next to it, and then we'll look to build a contradiction, and then from that contradiction we can tilde in the thing that we are looking to tilde in with. So as I said, let's just do the practice problems here. The first couple will be relatively easy, pretty basic, and then you should be able to build from there a better idea of what the rule is, and then we'll just keep working on it. This is probably the most basic version of the tilde in proof, so let's just go through it line by line. So beginning like we always do, we have our premises that get listed here in the first couple lines. And now, just like with every other proof, like I've been trying to tell you, the next thing you should do after you list your premises is look straight at the conclusion. And what's the main operator in the conclusion? Well, the main operator is this tilde. So whenever you see a tilde in the conclusion, almost 9 times out of 10, at least in this class, it's not necessarily the case if you take every other logic class, but for our purposes here, being an introductory level, I'm not going to try to fool you or trick you. If you see a tilde as the main operator in the conclusion, you know that your next step should be to assume the opposite of whatever has a tilde next to it. And we're going to mark it as a PA. And then remember, PAs get the same treatment as a regular assumption, just they have to get worked out of the proof by the end of it. So now, given what we've got, we can take this P in line 3 and toss it into line 1 to get Q. So that'd be from 1 and 3, arrow out, and 1 and 3 go here. Then what we're looking to do when we assume the opposite of this, so we're going to assume the opposite, and we're going to look to try to get to some contradiction. And we can build that contradiction here in 5 because I have a Q and a not Q. So we have to create that using our ampersand in rule. And with it, we can tilde in on our PA from 3 and 5, tilde in. And then just like arrow in rule, we remove the PA assumption that's associated with it. We remove the 3 as soon as we do tilde in. But let's go through this and just look back at what we've got. So we've got the opposite of our conclusion here, and we marked it as a PA. And what we're looking to build is this right here, which you see as one thing here, it's the Q and the not Q, but it's always going to be the same principle. It's looking to build a contradiction in which you have something on one side and the exact same thing on the other side, just with a tilde as the main operator on it. And so contradictions can look like Q and not Q there, but it could also look like P and Q and not P and Q, or it could look like P arrow Q and not P arrow Q. These are all contradictions. What's not a contradiction is something like this. That's not a contradiction. That's not a contradiction. Neither of those are contradictions. It has to be the exact same thing on both sides, where there's just a tilde operating on the whole statement on one of those sides. So again, with practice, you'll get this, but the important thing is, for understanding the rule, that when you cite the rule, you're citing your PA, which is going to be the opposite of your conclusion, and then you're going to cite where the contradiction is, which is going to say, I have this and not this. And the whole point of a contradiction is saying that things have to be either true or false in logic, at least in the system that we have. There are people who are dialectic or fuzzy logic. We don't get into that in this class. But the point is, for our logic, everything has to be either true or false. And so if everything has to be true or false, and you get to a statement in which you have something that is both true and false, what this statement here in 5 is really saying, Q is true and Q is false. And if you have a situation of that like that in logic, you know something is wrong. And from a contradiction, you can build whatever you need to, because it's logically uh, not correct. It's just unsound. It's and and the whole point with a contradiction is saying that if I made this assumption, it leads to this conclusion, and this can't be a possible conclusion. You can't have a contradiction that you derive. And so, because you can't have a contradiction, it has to be the opposite of whatever the thing is that you assumed. So that's a little bit of the inside the mind of what the tilde in and the tilde out rule is supposed to be. Not that you have to know that per se, but it's just important to sort of round out what you're trying to do here, and the idea of what we're trying to do, and that is, we're assuming the opposite of something, and we're showing that it can't be this opposite thing, so it's got to be the other it's got to be the other truth value. It can't be true. It has to be false. That's tilde in. The opposite will be true when we do tilde out, where we um, take something, we assume that it's negated or it's false, and then we show that it has to be true. So as we move forward, I hope it becomes a little bit more clear, but that is some of the basic idea of what is in this proof for tilde n. This proof is going to be a little bit similar to the previous proof, but it just goes to show what a contradiction really is, and fortify what we're doing here with the rule. So same thing as before, and every other proof, start with your premises, mark them as A's for assumptions, and then look at your conclusion. My conclusion is a tilde Q. And as I told you, whenever the main operator in the conclusion is a tilde, just assume the opposite of it and look to build a contradiction. So we're going to assume Q, and we're going to look to get to some contradiction, something in which I get the statement on one side and the same statement on the other side, just with a tilde in front of it. So we mark this Q as a PA, give it its own line number there. And now we're looking to build a contradiction. Well, I can't do anything with this here because the main operator is the tilde. I don't have a tilde out rule. I can't just remove the tilde. But based on what I've got, I can build the same statement like this. So from 2 and 3, ampersand in 2 and 3. And now I have my statement in which I can write P and Q and not P and Q. That's going to be a 1 and 4 and in. 4 is 1, 2, and 3. And then now that's a contradiction. That is I've got a thing written on one side and I've got the exact same thing written on the other side just with a tilde in front of it. And so from our contradiction, we can put a tilde next to our PA. We cite our PA, we cite our contradiction line, we do tilde in, and 1, 2, and 3, but the 3 drops out, so really it's not there. And that's this proof. But this goes to show you what a contradiction can look like beyond just a standard one letter Q and not Q, P and not P. This is a complex statement, and it's a contradiction because it's the exact same thing on both sides, just one has a tilde in front of it. So let me just clean this up just so you get a better view of it. But that is the second proof. Now let's do a little bit more complicated one. And as you'll probably realize once we start moving forward in this half of the semester or this portion of the semester, these proofs are going to get a little bit more lengthy, but they shouldn't be any more complicated. We just have more rules at our disposal now, so they're going to be a little bit longer than the traditional 5-6 lines we have been doing. So, same thing as before, we've got a conclusion that's a tilde, so we're going to assume it's opposite. Mark it as a PA. Now we're going to look for a contradiction. Some contradiction. Well, I don't see one immediately right now, so let's just do what we can do. We can't do anything with 1 because I don't have the P by itself, but I can break down the P and Q into its simplest parts, like this, using our AND out rule. Now I can toss that P into line 1 to get tilde Q and S, and that might be a piece of our contradiction because I got something with a tilde in front of it. But first off, we got to do 1 and 4, arrow out, 1 and 2, that. Now, this, like I said, could be a part of a contradiction. Can we build Q and S? Well, we can because I've got Q in line 5, I've got S in line 3, so it's going to be 3 and 5, ampersand in. That's going to be 1, 2, and 3. Then we can put 6 and 7 together, Q and S, and not Q and S, doing 6 and 7, ampersand in. And now that's a contradiction. And so in line 9, I can tilde in on my PA, so it's going to be 3 and 8, tilde in, and then 1, 2, and 3. Since I did tilde in, we get rid of the 3, and it's just 1 and 2. Like that. Moving on to question 4, I guess problem 4. We have our premises here, and we've got our conclusion, which is a tilde Q, so I'm going to write its opposite. I'm just going to write Q by itself here, mark it as a PA, associated with line 3. Now, here again, not immediately sure what my contradiction is going to be, but this is a pretty good possibility because it's got a tilde in front of it. I could possibly build Q or R because I've got Q here in line 3. So maybe I go ahead and do that. Maybe I build Q and R from 3 wedge in. And so that's going to be from 3. And so that might be my square. So now I just need to work to get my tilde Q or R out of that conditional statement there. So let's work to do that. And what's the antecedent for that conditional statement? It's P or T. I don't have that yet, but I can build it by wedging in the T on 2. like that. And now I can take this P or T, toss it into my conditional statement in 1 to get tilde Q or R. So that is going to be from 1 and 5, arrow out. That's going to be 1 and 2. And then we can build our contradiction. So I've got here and here. So I'll put those together. Q or R. And not Q or R. And that is going to be from 4 and 6, ampersand N. 6 is 1, 2, and 3. And then we can take our PA, we can tilde in on it. So it's going to be our PA is in 3, our contradiction is in 7. And so we'll just tilde in. And so that includes 1, 2, and 3. But the 3 drops out. And so we just have 1 and 2 left in our premise lines on the left-hand side. Moving on to 5, we've got 2 different assumptions here. And importantly, this is our first proof using tilde in which our conclusion is not a simple tilde. So to drive home the point, the idea is I have this whole thing in the main operators as tilde in front of it. So when I go to 3, I need to make a PA, and I need to make a PA of the opposite of what that conclusion is. So here I'm just removing the tilde and I'm making it a PA in line 3. Now I'm looking to build a contradiction. So with what I've got, I can't do much right now. I can separate my second premise here by doing ampersand out. And now I can take that Q and I can get a T here in line 6. So that's going to be 3 and 4. Arrow out. 3 and 4 have 2 and 3. Now I can build the antecedent to my conditional statement in line 1. So I can do P and Q. 4 and 5, ampersand N. 4 and 5, that's going to be just 2. And now I can toss this into my conditional statement in line 1 to get tilde T. So that's going to be 1 and 7, arrow out. 1 and 7 have 1 and 2. And here is my contradiction. I've got a T and a not T, so I can put those two together. 6 and 8, ampersand N. 6 and 8 have 1, 2, and 3. Now I've got a contradiction. I've got a PA in which the contradiction depends upon, so I can just tilde in front of it. Like so. So my PA is in 3. My contradiction's in 9. And what am I doing? I'm doing tilde in. So that's going to be 1, 2, and 3. But the 3 will drop out, so it's just 1 and 2. Now it's important to note that this tilde Q arrow R, the main operator is the arrow here. Or not the arrow, sorry, the tilde. But if this were the conclusion, or probably just get something a little bit closer to the actual conclusion, say if it was this, then the main operator is actually the arrow. It's not the tilde, because the tilde is only associated with the Q here. So when you see the conclusion, it's got to be the main operator. You're looking at the main operator and the main operator. In this conclusion in 5, it's tilde parentheses. But if you don't have the parentheses, then the main operator shifts to the arrow. So remember, you have to be able to identify what the main operator is. Moving on to 6, we've got 2 premises again. and our conclusion is a tilde P, so we're going to assume the opposite of that, mark it as a PA. And we're going to look for a contradiction. And we might be able to see it right away because I've got a tilde S here and a regular S here. So I should just go ahead and look to get those two. So I could go ahead and separate the S out of 2 here. And then I could create the antecedent that I need with P, doing wedge in. And then I've got this as my antecedent I can toss into here to get the tilde S. And then from, or I guess first I should note this is from 1 and 5, arrow out. 1 and 5, 1 and 3. Now, I want to put my S and not S together, which is going to be 4 and 6, ampersand in. 4 and 6 is 1, 2, and 3. There's my contradiction. I just need one more line here because I need to tilde in on my P. And that's going to be 3 is my PA, 7 is my contradiction. I'm doing, or I'm introducing a tilde in front of my PA to be 1, 2, and 3. Mark out the 3, so it's just 1 and 2. Problem 7 is pretty similar to the previous problem. We've got two premises here. Our conclusion is just a single letter with a tilde in front of it, so we know we're going to assume it's opposite as PA. We're going to look for a contradiction, and you might be able to see it right now. I've got an S here and a tilde S here, so I should just build towards that. If I can get those, then I can just do ampersand in, get my contradiction, then tilde in on my PA. So to get to that T and not S, I need the antecedent of line 1. I can write that in line 4 by wedging in the P to the Q that I get from my PA. And then I can take that, I can get my T and not S from 1 and 4, arrow out. 1 and 4 is 1 and 3. Then I can ampersand out to get my tilde S, and that's going to be from 5, ampersand out, 1 and 3. And then now I've got a S and a not S, and I'll just put those two together, doing 2 and 6, ampersand in, 1, 2, and 3. And finally, since we've got our contradiction, we've got a PA in which the contradiction depends upon. We can tilde in on our PA. We'll cite our PA, which is in line 3. We'll cite the contradiction, which is in line 7. We'll do tilde in. That's going to be 1, 2, 3. But since we're doing tilde in, the 3 drops out as soon as we apply the rule. This problem's a little bit simpler. It's a little shorter. So, 2 premises. But the important thing about this proof is that, again, the main operator is the tilde here. So we're going to assume the whole thing. We're going to assume P or Q as a PA. And we're going to look for a contradiction. Now, easily enough, we could toss this P or Q into line 1 to get S. So that's going to be 1 and 3, arrow out. 1 and 3 like that. Now I've got S and not S. So that's 2 and 4. Ampersand in. Let's do 1, 2, and 3. And now I've got a contradiction. I've got it depending upon my PA, so I can just tilde P or Q. 3 is my PA, 5 is my contradiction. I'm introducing a tilde, and so we do 3 and 5, tilde in, we remove the 3 at the end, so it's just 1 and 2. But the important thing again is that we are assuming everything on the right side of the tilde. Now, you could make this proof just as well by assuming, I'm gonna change this up just a little bit, and then I'll get it back to where it was. Let's erase these lines here. So now imagine I was doing this, and I said, well, why don't I just assume P here, because I can wedge in the Q, doing 3 wedge in, and that would give me S from 1 and 4, arrow out, and then I can do S not S from 2 and 5, ampersand in, 1, 2, and 3, and then I could do, you might think, well, why don't I just do tilde P, or yeah, do it this way. It's hard to think about the wrong moves that would get made, but I can understand this happening. So you would do 3 and 6 tilde in, 1, 2, 3, then make an 8. And you might think, well, I'll just wedge in that and that. But that's not what we're looking to prove. We're not looking to prove tilde P or Q. We're looking to prove that the whole statement itself is false. So if I was looking for, let's just erase this. This would be the proof if we want to do something like that. But that's not necessarily what we're looking to prove with tilde parentheses P or Q. So importantly, there's a difference here, and you gotta be able to recognize exactly what we're trying to prove and how to go about doing it. In this instance, I probably won't ever give you anything this difficult because the main operator is not a wedge, and you're not really thinking based on 3 or 4 steps ahead most of the time, especially since this is just an introductory course. We might do a couple more that are like this proof here in the next set of practice problems, but just know that this conclusion and this are not the same. Those are 2 different statements. So that's problem 8, and then problem 8b, if we want to call it, with the adjustment of changing the conclusion around. So, but that is problem 8. Now practicing problem 9 here, we got 2 premises. And we've got a tilde as our main operator in the conclusion. So we know that our step 3 should be to write the conclusion just without the tilde as a PA and look to derive a contradiction. Now you might immediately see I've got an S and not S, so let's just try to build that. To build that, we just need the antecedent for the first line conditional here. We can take out either or. We can take out the Q from 3 ampersand out, and then we can wedge in the P, doing 4 wedge in. We could have just as easily done P. Didn't matter which one we take as long as we take one of them. And then from this we can get our conditional out from 1 and 5, arrow out. 1 and 5 is 1 and 3. And then we can ampersand in our S and not S. So that's going to be 2 and 6 ampersand in. That's going to be 1, 2, and 3. And now our PA in line 3 depends upon, or sorry, our contradiction in line 7 depends upon our PA in line 3, so we can tilde in Q and P. So that is going to be 3, 7, tilde in. So that's 1, 2, and 3, and then we can drop, or the 3 drops out as we do tilde in, like that. So that's problem 9. Now for problem 10, got 2 premises. We've got a tilde as our main operator in our conclusion. So we're going to write the opposite of it like this. That's going to be PA. Mark it as 3. And then we can separate out our conjunction here in line 3. Which gives us the antecedents for both of our conditionals in 1 and 2. So I can write Q from 1 and 5, arrow out, 1 and 3, and not Q from 2 and 4, arrow out, 1, 2, and 3, and then Q and not Q from 6 and 7, ampersand in. Now that's our contradiction that we needed, and we've got a PA that depends upon, so we can just tilde in on our PA. So it's going to be 3 is our PA, 8 is our contradiction, we're tildeing in, and then 1, 2, and 3, and the 3 drops out. So that is problem 10. In the next set of practice problems, we might get a little bit more difficult and introduce a couple of instances in which the tilde is not the main operator in the conclusion, but you still need to do tilde in. So like I said, these get a little bit more complex now that we're introducing more rules and some of the more difficult rules as well. So that does it for the introducing of tilde in and these first problems.